Okay, we are on 3.6, combining functions. And let's take a look here. We have the sum, difference, product, and quotient functions.
Hey, Doc, we better back up. We don't have enough roads to get up to 88. Roads?
Sum of functions. Basically, that is just taking the first function and adding it to the second function. That's what we call f plus g. And this is how you might see it written, f plus g of x. You might also see it written as f of x plus g of x. So it's just a couple different ways of saying, hey, take two functions, two different functions, and add them together.
Tina, you fat lard, come.
Difference of functions, it's just subtracting. So you take the two functions and you subtract them. That's really all you're doing. And here are the different ways that you might see them throughout doing it. You could have f of x minus g of x, which is this one at the bottom, or you could have the f minus g of x. It's the same difference.
Oh, thought you were going to tell me.
Products of functions. Product means multiplication, so this is just taking two functions and multiplying them together. You could have f times g of x, or you could have f of x times g of x. It's just multiplying the two functions together. That's literally all that it is.
Time circuit's on. Flux capacitor.
Quotient of a function is division. So it's taking two functions and dividing them. It's f of g of x, and once again, these are other ways that you might see them written, f of x divided by g of x. But keep in mind, g of x cannot be 0. Okay, so g of x can't be 0, because if it is, then you'll have something that is undefined.
Have some fruit spray? Fruit spray?
So if I gave you f of x and I said that that was 3x minus 2, and then I gave you g of x and said that was x to the third power. If I said, hey, add them together and plug a 2 in for x, subtract those two, but also put a 2 in for x, multiply those two, but put a 2 in for x, and then divide those two and put a 2 in for x, is basically what all of those are saying. So this first one, it's basically saying put a 2 in here and put a 2 in here. Get answers for each of those and add them together. So here's the first one. I plug in a 2 right there, and the second one I plug in a 2 there, and then I'm going to add them together. So 3 times 2, I get 6, and 6 minus 2 is 4, and 2 cubed is 8, so 4 plus 8 is 12. So the answer to the first one is 12. The second one's saying, hey, take a 2, plug it in here. Take a 2, plug it in here, but subtract them. So that's what I'm doing. So we already did all this math up here before. We got 4. And we already did all this math over here. We got 8. So now instead of 4 plus 8, we're just doing 4 minus 8. And 4 minus 8 is negative 4.
Pauline, give me some of your tots.
So continuing, now we're multiplying. But I'm going to plug a 2 in for each of them. So I plug in a 2. So it's 3 times 2, which is 6. 6 minus 2 is 4. And 2 cubed is 8. So really I'm saying, hey, what's 4 times 8? And that's 32. And then this one is saying, hey, divide the 2 and plug a 2 in for them. So I'm going to plug a 2 in for the first thing and a 2 for g. And I'm just going to divide them. And we've been saying the f, when you plug in 2, f of 2 is 4. We've been saying that g of 2 is 8. So really I'm basically going to ask, hey, what's 4 over 8? 4 over 8, when you simplify it, you end up getting 1/2.
Ron, where are you?
So now we have f of x equals the square root of 4 minus x squared, and g of x equals 3x plus 1. Now I want you to do the same thing. You add them together, you subtract them, you multiply them, and you divide them. Okay. However, this is just saying, hey, don't plug in a number, just keep it as x. So f of x plus g of x. Take f of x, take g of x, and add them together. So when you do, I get this. If there's any terms that are alike, you want to put them together. If there aren't any terms that are alike, then you can't put them together. This is all under a square root sign, and this is not. So I can't put those items together because even though this is a number underneath here, I can't just square root both those because there's a subtraction sign in the middle. So there's really nothing I can do here besides keep it written as is. The next one is subtraction, so I take the first item minus the second item. Now, here's the only difference. There's still nothing I can put together, but since it's minus the entire g of x, I need to take a negative sign through to both of those. So when I do that, I end up with the square root of 4 minus x squared, but now it's a minus 3x and a minus 1 because I had to take that subtraction sign through to both those items.
What are you going to do today, Napoleon?
Now I'm going to be multiplying the two together. So I have f of x and g of x, and when I multiply them together, basically have them side by side. Now, I could, I guess, take that through and get a 3x times the square root of 4 minus x squared, and then also take the 1 through, but it's really not going to make much of a difference if I do that. It's just going to write the answer out longer, so I'm just going to keep it written as is. And dividing the two, the only thing we have to catch here is basically f of x, which is this, over g of x. Now the only problem that I can foresee with a division problem is you can't have roots in the bottom. So if you have any roots on the bottom, you're going to have to get rid of them. So we were lucky enough in this problem that the root was on the top and not the bottom. So there's really nothing for us to do.
Brother? I'm Paul.
So we're going to have to find the domain of each of these. So remember the rules for domain from earlier in the chapter. You take whatever's underneath and set it greater than or equal to 0. So when I go to solve this, I subtract 4. So I get negative x squared is greater than or equal to negative 4. Divide both sides by negative 1. I have to also flip the sign, so I get x squared is less than or equal to 4. I square root and I get plus or minus 2. So I basically can either A, look at the graph and see what the answer is going to be. I know it's going to be something to do with negative 2 and positive 2, or I can test points because it's an inequality. The answer here is between negative 2 and 2 because the graph is a half circle, so it's going to be everything in between those 2 points. So that's why I know it's in between negative 2 and 2, and there's square brackets because it's actually touching those 2 points. The domain for 3x plus 1, if there's no roots, if you see absolutely no roots in the problem, if you see no fractions with x's in the denominator, then basically it's going to be from negative infinity to infinity, so all real numbers.
Whoa, wait a minute.
So when we add those two together, we need to find where the domains overlap, and that will be your new domain. Where do the two domains overlap? So f of x we said is in between negative 2 and 2. We said g of x is between negative infinity to infinity. They overlap at negative 2 to 2. So this is going to be from negative 2 to 2. This one, where they overlap, it's the same two domains. That one's also going to be negative 2 to 2. This one, same two domains, still going to be negative 2 to 2. And this one, there's only one difference. The top is negative 2 to 2, but remember the bottom is a fraction, 3x plus 1. You can't have an x on the bottom. So I have to get rid of that x, and we cannot equal 0. So I minus 1 on both sides, so I get 3x cannot equal negative 1. I divide both sides by 3. So I get x cannot equal negative 1/3. So really, I have to skip over that. So it goes from negative 2 to negative 1/3. And it's a curved bracket because it doesn't touch that point. Union, then curved bracket starts right up again from negative 1/3 to positive 2.
Great Scott.
Composition of function is what we will do when we come back.